Okay, the last section that we're going to look at is section 7.1, which is on trig identities. All right, so you need to write the following notes in your notebook. All right, so we're going to talk about proving trig identities. So there's three important things to know when proving trig identities with one side of the identity. Okay, so when you're proving trig identities, you do not perform operations on both sides of the equation. Okay, you only work with one side of the equation. All right, so we do not add to both sides or divide on both sides. We only work with one side. And you want to start by choosing the more complicated side to work with. Okay, the second thing you need to know is you need to use the identities that I gave you, the page of identities. And in order to use those identities, sometimes you need to factor, simplify fractions, or find common denominators. Okay, and then the last thing you need to know is that sometimes converting all of the other trig functions into sine and cosine can be helpful in simplifying. All right, so we're going to look at two of these together. Okay, the first one is we're going to prove the identity cosine of theta times the quantity secant theta minus cosine theta is equal to the sine squared of theta. Okay, so we're going to prove this, and we're going to do so by writing it in terms of sine and cosine. All right, so you want to start by working with the more complicated side. All right, so we are going to we're going to work with the left side. And that means we're going to take the left side and we're going to try to turn it into the right side. Okay, so I'm going to start by writing down the left side again. So cosine theta times the quantity secant theta minus cosine theta. Okay, and we're told to prove it using, or by writing it in terms of sine and cosine. You won't always, or you won't be told what method to use in solving, but this is a common one. Okay, so what I'm going to do is I'm going to use substitution here, and I'm going to rewrite the secant as 1 over cosine theta. All right, and that is one of our reciprocal identities. So over here on this side, I'm just going to write substitution because that's what we used. Okay, and when I do my work, I'm going to write my reason on the right side so that hopefully that helps you to follow along as to what I did. All right, the next thing I'm going to do is I think I'm going to distribute. All right, so the cosine times 1 over the cosine is cosine divided by cosine minus cosine squared. So all we did there was distribute. Okay, this is just 1. Anything divided by itself is 1. Okay, and I'm just going to write down multiplicative inverse, because that's really what that is. Oops, not multiplication, multiplicative inverse. All right, and then 1 minus the cosine squared of theta, that's one of our Pythagorean identities. That is equal to the sine squared of theta. That is substitution. And we are done. We've proved that cosine theta times the quantity secant theta minus cosine theta is equal to the sine squared theta. All right, we're going to do one more identity. All right, so this one we're going to prove by finding common denominators, okay, and writing as one fraction. All right, so I want you to write down the tangent squared of theta minus the sine squared of theta is equal to the tangent squared of theta times the sine squared of theta. So we want to work with the more complicated side, and generally if one side is multiplication and the other side is addition or subtraction, this is going to be the more complicated side. It's going to be the easier side to work with. Okay, so I am again going to work with the left side. All right, so I'm going to write down the left side, the tangent squared of theta minus the sine squared of theta Okay, and I think the first thing I'm going to do is I'm going to rewrite these in terms of sine and cosine. All right, so I can see that the tangent squared is sine squared theta divided by cosine squared theta. All right, and that's just substitution. That's one of our quotient identities. All right, so all I've done is substituted the tangent with sine over cosine. Okay, so we're gonna try to find common denominators here. So I have a fraction, and then I have something that's not a fraction. So that means that I can use cosine squared theta as the denominator that I want. So I'm going to take sine squared theta and I'm going to multiply it by cosine squared theta over cosine squared theta. Okay, so then these two will have the same denominator. So over here on the right, just going to write common denominator. Okay, because that's what we're doing here. Okay, and then in the next step, I'm going to write these as one fraction. Okay, so the sine squared theta minus sine squared theta cosine squared theta all over the cosine squared theta. All right, and then what I'm going to do is I'm going to work with my numerator. So in the numerator, I have a greatest common factor. Okay, so my next step is going to be taking out that greatest common factor. So I'm going to divide both of these by sine squared theta. Okay, and I'm going to just write what I did over here. Factor out the greatest common factor. Okay, and then I want to look at what we're trying to get to. This is where we're trying to end. So we want a tangent squared theta and a sine squared theta. So this right here, I can replace with tangent squared theta. Okay, that is tangent squared theta. Okay, 1 minus cosine squared is sine squared theta. So that's again substitution. And we're done. We've proved that the left side is equal to the right side. Okay, so I have 4 of these for you guys to try. And I'm also going to put up my solutions. All right, so number 30 is the tan of theta divided by the secant, of x, is equal to the sine of x. I think it's probably pretty obvious that this is the side that you want to work with. Okay, number 32, the cotangent of x times the secant of x divided by the cosine of x, cosecant of x equals 1. Again, you have to work with the left side here. There's really nothing to do with the right side. Okay, this one looks complicated, but this is probably the easiest one here. 54 is the sine squared of alpha plus the cosine squared of alpha plus the tangent squared of alpha is equal to the secant squared of alpha. I think you can do this one just by working with the identities. So use the Pythagorean identities. Sorry, let me write Pythagorean. Okay, and then on this one, this is just like the last one I did. So you're going to want to work with this side. And you're going to need to get common denominators, just like we did in the second example. All right, and see how far you can get on these. And if you get stuck, I'm going to put my answers up. I at least want you to write everything down, and I've labeled all my steps. And we'll spend some more time on this on Tuesday. Okay?